Let's open our SPSS dataset for practical section. Our SPSS dataset as shown. So this is the ID. We have 60 students that participated in this study. This is study as test score, social media has. So we have 3 variables here. So how do we check for normality? Go to Analyze, click Analyze on the top menu, move down to Descriptives, click then go to Explore. Now, you will see the 3 variables here: study has, test score, social media has. Let's do the normality checking and test on study has. So let's pick study has to the dependent variable list. And then click on statistics, allow it to be on descriptives. So click continue, click on plots. Ensure that you tick histogram. Ensure that you tick normality plots. And also ensure the stem and leaf here is ticked, very important. When you're done with that, click continue. And then check that the both here is ticked so that you can have both statistics and plots. If you want only one, then you can then tick only one of these. And when you have done that, click OK. When you have clicked OK, the results should show, and this result will show. Let's expand it so that we can see. Now, these are results. And we have here the case processing summary, which tells us that we have 60 respondents, and they were all valid cases, and there was no missing case. And this is descriptive statistics telling us the mean here and standard error. And then, very important, check this skewness. This skewness could give you very important points. And then the skewness here tells us 0.01. Now, this 0.01 is closer to 0. Now, it's signaling to us that this particular data is likely going to be normally distributed. If it was like 0.7, 0.9, then it will have signaled that this data will not be normally distributed. So this data is likely going to be normally distributed. It's a signal. And then if you like, you can also check your standard deviation, 2.3, which is not bad. So now let's move to normality. Under the test of normality table, check the Shapiro-Wilk, which is very important. This Shapiro-Wilk is not expected to be significant. Do you know why? If it is less than 0.05, it means it's statistically significant. And when it is statistically significant, it means that the data or that variable is not normally distributed. So this is 0.467, which is greater than 0.05. And therefore, this data is normally distributed because it's greater than 0.05, because it is not significant. That is why it is normally distributed. Now, let's look at histogram. The histogram here is also another evidence telling you that this data is normally distributed. Look at it well. You will realize that if I should create a bell-shaped curve here, it will look like this. And you see, I'm clicking it again, a bell-shaped curve, it will look like this. So telling us that most of the students study more around 4 hours and 6 to 8 hours. So because we can be able to create similar curve like bell-shaped curve, so it's normally distributed. Though we also know that it has slightly as higher here, but it's not much. So this data is normally distributed. So look at the stem and leaf plots. You also notice that it runs from 0 to 9. Look, the first line 0, 1, then 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 6, 7, 7, 8, 8, 9, 9. You see, there is no mix-up. It also runs in linear motion. So automatically, this is also evidence that this data is normally distributed. That means the study is normally distributed. Let's check normality, normal GG plot of study hairs. Let's see what happens. You see, the points here, the points are very close to the diagonal line, which tells you that this data is normally distributed. If it wasn't normally distributed, you will have been seeing some points here and some points flying here to this corner, either up or down, but they are very close to the diagonal line. It's normally distributed. Let's look at the trend normal GG plot of study hairs. You see, the normal GG plot of study hairs is the deviation line showing the deviation from normal, but you notice that the points also spread across, not too far from this deviation line, and they are not very far like at this point, and they are not far as of this point. So this is also an evidence that it's normally distributed, although not very, very highly normally distributed, but it's normally distributed at this particular point. So now let's look at this. You look at this. This is the box plot. This box plot, look at the difference, the gap between this top, the deviation between this top and here and this point, and also from this particular point to this point, you will notice that they are almost similar in terms of distance. The spaces or the gaps are similar. This is an indication that this data is also normally distributed. Look at the box plot, it's in the middle. You see, look at the box plot is in the middle here, and the deviations are just also, the box is the middle, and deviation is almost similar. So this is an indication of normally distributed. This step is very important because it determines whether you should use Pearson's correlation or Spearman's rank correlation or regression analysis or any other form of analysis. If you found this helpful, click like, subscribe to the channel, and share with someone using SPSS or working on data analysis. Drop your comments and I will be happy to address them. Thank you very much. And see you in my next lecture.